everyone, this is the last live video for the year, and the topic is derivatives of exponential and log functions. This video is 100% just working through some examples of how to find some derivatives. The other video has all word problems, finding slope of tangent lines, and how to use your calculator. There are two other attachments. One says derivative of log functions, and that is compliments of Mr. Martinez, and he worked through the proof. Then there's another attachment that was attached last week, and that's on inverse trig functions. But if you go down to the last page, he also does a proof of the e to the x. I really recommend that you go through them. Do you have to know how to know the proof this year? Of course not, but you probably are going to need to know it next year for BC. Okay, so there are 4 derivatives that we're going to take a look at, and I'm just going to write them on the board so we have them. The derivative of e to the x is e to the x dx. It's the derivative, it's just flat out the function and then the derivative of the exponent, so to speak. Then we have the derivative of a to the x, and that is a to the x times the natural log of a, where a is a base. A is a base that's not e. You can see I have my little cheat sheet here. It's been a long time since I've used them. The derivative of the natural log of x is 1 over x. And then, of course, dx times the derivative of whatever the argument is. And then this should say d dx of x. This should also say d dx of x. Exponent, the argument, which is x, then this should also say the derivative of a. Okay, and then the last one is the derivative of the log. Do they use b? I always use b and a. They use a and x, which I find confusing, but whatever. 1 over the argument times the natural log of the base. Okay, so I'm just going to go through some quick examples. I'm going to do 3 of them, I think. Okay, this is number 8. I didn't want to carry the book in my hand, so I did it on a piece of paper instead. All these questions, I think I'm doing 4. We're just doing straight out find the derivative, okay? That's the directions for 1, 2, 3, 4 problems I'm going to do. Okay, I feel like I've been facing the board. All right, product rule, be careful with the subtraction. So I'm going to take x squared times the derivative of e to the x, but the derivative of e to the x is simply e to the x plus e to the x times the derivative of x squared, which is 2x, minus, I always say the first function times the derivative of the second function. So the first x times the derivative of e to the x, which is e to the x, plus the second e to the x times the derivative of the first, so the derivative of x is just 1. All right, let's distribute, combine some like terms. So this is x squared e to the x plus 2x e to the x minus x e to the x minus e to the x. That's a lot of x's and that's a lot of e's. Okay, we can combine like terms. 2x minus x is x. So our answer is x squared e to the x plus x e to the x minus e to the x. For me, one of the hardest things about these problems is that they're not nice, neat answers. Like, that's it. That's the answer. Okay. Let's look at number 14. Our days of getting nice answers of 2, -16. Those are pretty much done. Number 14. Three to the cotangent of x. 3 to the cotangent of x. Okay, so that falls, the base is not e, the base is something a. Why don't they use b for base? It drives me crazy. Anyway, so a to the x. Our function is y equals 3 to the cotangent of x. Times the natural log of the base. The base here is 3. Times the derivative of the exponent. So the derivative of cotangent, I believe, is negative cosecant squared. I'm pretty sure. I better check I did that right. Yeah. Okay, so this is going to become negative 3 to the cotangent of x power times the natural log of 3 times the cosecant squared of x. That's it. That's it. I wish I could simplify it more. I bet you do too. Okay, 2 more. Number 28. And 28, when I first chose to do this problem, I thought, that looks really complicated. And I don't know why, but I thought it was super complicated. Don't be fooled. Okay, so the natural log of 10 to the x, and I'm sure you're thinking, this is not that complicated. Great, good for you. I thought it was complicated at first. Okay, so the power property of logs, exponent, make it a coefficient. So this becomes y equals x times the natural log of 10. Okay, and then the directions want us to find the derivative. Great. So if I want to find the derivative, and I'm going to show you what I did, and hopefully as you're watching, you can figure out where I went wrong. So I said, okay, product rule, x times the derivative of the natural log of 10 plus the natural log of 10 times the derivative of x. Where's my mistake? Yeah, the derivative of the natural log of 10 is 0. It's not 1 over 10. It's a number. The natural log of 10 is just some fancy number in our calculator. So, really, in all honesty, this is no different than saying some number, 5, times x. What's the derivative of 5x? 5. So just because it says natural log of some number, that's not as complicated as it might seem to you. It seemed very complicated to me. I forgot, oh, the natural log of 10, that's whatever, 2 point blah blah. So the key to start this problem is to remember the property that says if you have an exponent, it becomes a coefficient and you multiply. That's the power property of logs. This is simply the natural log of 10. One more, and the last one we're going to do requires that you remember some of your properties of logs, which I'm sure you remember every single one. This is number 24. This is number 24. 1 over the log raised to x. 1 over the log base 2 of x. Okay. That's the same thing as the log base 2 of x to the negative 1. Log base 2 of x to the negative 1. Okay, now to derive this, I'm going to use the chain rule. That's negative log base 2 of x to the negative 2 times the derivative of quote-unquote what's inside, and that is 1 over the argument, 1 over the argument, which is x, times the natural log of the base. Rewrote it, negative exponent, chain rule, negative 1 comes down in front, decrease the exponent, and then this comes from the derivative of what's inside, and what's inside is the natural log, what's inside is the log base 2 of x, and the derivative of the log base 2 of x is 1 over the argument times the natural log of the base. Okay, great. Negative 1 over x times the natural log of 2 times the log base 2 of x squared. Just simplifying? Okay, so we can simplify that. We can simplify this further. So off to the side. Change a base. Change a base for logs. I can make the base anything I want. Your calculator does it for you, right? Like alpha window 4, I want to say. This is the log of the argument over the log of the base. Log of the argument over log of the base. Well, what's the new base? 10 generally. But I could make it base 6 if I want. I could make it base 20 if I want. I could make it base purple if I want. Let's make it base E. Miss Babiak, you can do that? Absolutely. Mathematically, as long as they have the same base, you get the same answer. Well, I don't write log base E, right? What's log base E? Natural log. Okay, so what I'm going to do is I'm going to pull out the log base 2 of x, and I'm going to do the change of base property. The log base 2 of x is the natural log of x over the natural log of 2. The log base 2 of x is the natural log of x over the natural log of 2. Natural log of 2, it's going to help me. Now, 1 over the log base 2 of x is the natural log of 2 over the natural log of x. There are no derivatives in this at all. This is all algebra. So here we go. Negative 1 over x times the natural log of 2. And then this is the natural log of 2 squared over the natural log of x squared. Okay, So this becomes negative natural log of 2. You can reduce. This becomes 1. And, sorry, let me rewrite that. Okay, so squared becomes a 1. That reduces out, and you get x times the natural log of x squared. Literally, I just did change of base. I did a bunch of funky log stuff that you haven't done in a really long time. And then honestly, this is just some algebra, multiplying by the reciprocal, reducing, etc. And that is number 24. Next video, make sure you have your calculator, and I'll be doing some word problems and some of like the slopes of the tangent lines.